So in one of the previous chapters or maybe in previous grades, you guys would have learned about mass and weight, right? And I hope you guys remember the difference. So mass is, well, what the material is made up of. Weight not only depends on mass, but also on gravity. Similar to this, we have something called as center of mass and center of gravity. Please note that they are not the same. They have different definition and different idea. Again, how we interchange mass and weight and how we loosely talk about it. Center of mass and center of gravity are also loosely interchanged. But yeah, technically they are different. So we are looking at the difference. So center of mass, it represents the average position of all the things that the object is made up of. While center of gravity is the average weight. Okay, so we are taking the average of the weight basically. So the factor that the center of mass depends on mass and how they are distributed, while center of gravity not only depends on how the mass and how it's distributed, but also on the gravitational field. Center of mass is used for understanding how objects move through space, while center of gravity is used for understanding stability. I have a official definition over here. So center of gravity is a point at which the resultant of the gravitational force on all parts of the body acts. That is a point where the whole weight may be assumed to act. So mathematically, let's have a look. So mathematically, we are looking at center of gravity. Gravity's position. Technically, it looks like this case. It is sum of weight time position for all parts. This entire thing gets divided with total mass. So technically, we have center of gravity, which is equal to sum of I is equal to 1 to n WI/RI divided by total weight. Okay, so this is your mathematical presentation. Maybe this is too much for now. Let me not write this. While we have center of mass, so look at the difference. Center of mass's position will be equal to sum of mass times of position for all parts divided by total mass. Sorry, oh my bad, this is total, not mass, total weight. Okay, so this is the basic difference, center of gravity and center of mass. Here it's weight, here it's mass. Now, there's a small note. Center of mass and center of gravity are the same for all objects which are exposed to the same gravitational force on all parts, while mountains will have different center of mass and center of gravity. So let me put it to you guys in this way. So this is clear, right? Now, what is weight? Weight is nothing but mass times of gravity. So let me convert it. So we have sum of mass times gravity into position for all parts divided by total weight is nothing but total mass, capital M, for example, into G. Okay, so this is your center of gravity. I should have written it a bit smartly. So this has to do with your center of gravity. Sorry, paste. Okay. Now, the thing is, when it comes to mountain, right? For example, case mountain. So we have a mountain. Mountain, because they're that tall, so you will study in the next chapter that the gravity will vary as and when we move away from the. If you move away, actually, you guys have already studied all of this. You might not remember. So this section has the same gravity. Okay. Say this till here, the gravitational force is different. Sorry, in this space, the gravitational force is same. In this space, it is same but of different value. Say this is x, this can be y, and this can be z, and this can be a, and so on and so forth, the values that is. So the gravitational value will be different over here in this space. So basically, my g will not be same for all the masses. So for in case of a mountain, g value, it varies. It varies. Okay, g value varies for different height. But when it comes to a case of a pencil or you or me, so a human being or a car also or a truck, whatever. So when it comes to this, g is same for all parts. I had to make that clear. G varies, value varies, or g value is not the same for all the parts. It's not same for all parts. While g is same for all parts over here. Why is that I am talking about this? When g is same, your center of gravity will be or can be written as g, we can take it out, then sum of mass times the position, okay, divided by, then we have g times of m. So can you see that g is there in numerator and denominator and it's the same? So what I can do, I can cancel this, and this formula is nothing but your center of mass. So center of gravity and center of mass are same when it comes to small things. Again, small things, I'm not talking about pencil or eraser, I'm talking about even a truck. For gravity, a truck is a small thing. Earth's gravity, that is. Okay, so what we have here is similar to how we have a debate about mass and weight and how we loosely, how we loosely interchange them in our conversation. Center of mass and center of gravity also are handled the same way. But of course, there's a technical difference. Weight and mass. But when it comes to small objects, right, we can see that the center of mass and center of gravity values of the position, they remain the same. Okay, so best example is again this video, wherein the motion of the pencil when we hit the center of mass over here. So that followed that rule that if you apply a force through a center of mass, it will move in a same straight line. All the parts will have the same velocity. And right, this is center of mass. The next part what I'm doing is to do with center of gravity. Okay, so this part was center of gravity, while the other part what I'm trying to do is to do with center of mass. Okay, so that is the difference. Okay, guys. So I hope I made the concept clear. So the basic difference that has to be very clear in your mind.